Welcome, dear students, to a new lesson. Today we'll be learning about the relation between the tangents of a circle. If AB is a chord in circle M and the two tangents L1 and L2 intersect at point C outside the circle, then both CA and CB are called a tangent line segment, where AB is called a chord of tangency. Theorem number 4 says what? Says the two tangent segments drawn of a circle from a point outside it are equal in length. So as you can see here, that we have two tangent segments, AB and AC. They are meeting outside the circle at point A. Then these two tangents are equal in length. So how to prove it? In triangle ABM is congruent to triangle ACM, therefore AB is equal to AC. Corollary number 1. The straight line passing through the center of the circle and the intersection point of the two tangents is an axis of symmetry to the chord of tangency of those two tangents. As you can see here in this figure, AB and AC segments are two tangents to circle M at points B and C. Then AM is an axis of BC as a chord. Then AM is perpendicular to BC and BD is equal to CD. Corollary number 2. The straight line passing through the center of the circle and the intersection point of its two tangents bisects the angle between these two tangents. It also bisects the angle between the two radii passing through the 2 points of tangency. As you can see in this figure, AB and AC are two tangents to circle M at points B and C. Then AM bisects angle A. Therefore, the measure of angle BAM is equal to the measure of angle CAM, where BA bisects the angle BMC. Therefore, the measure of angle AMB is equal to the measure of angle AMC. Let's see how to apply this on one of the examples. Example number 1. In each of the following figures, AB and AC are two tangent segments to the circle M. Find the value of the symbol used in measuring. In number 1, you will see that AC and AB are two tangents meeting outside the circle, so they're equal in length. Therefore, the measure of angle ACB is equal to the measure of angle ABC is equal to x. Then x equals 180 minus 50, and the result is divided by 2. So x equals 65 degrees. Then, since MC is perpendicular to AC, therefore, the measure of angle Y equals 90 minus 65, which is 25 degrees. Angle Y for sure is angle BCM that is labeled by Y. To find the measure of angle Z, which is angle CMB that is labeled by Z, you will see that the measure of angle Z equals 180 minus the sum of 25 and 25. So it's equal to 130 degrees. Or you can say that measure of angle Z equals 360, the sum of the interior angles of a quadrilateral, minus 50 plus 90 plus 90. Or you can say that the measure of angle Z, which is angle CMB, equal 360 minus the sum of 90 plus 90 plus 50. So for sure it will be the same, which is 130 degrees. You can find Z by either ways. From what we have studied from the corollary, you will see that AM bisects angles M and A. Therefore, x equal 35. MC is perpendicular to CA, as the radius is perpendicular to the tangent when they meet at the point of tangency. So MC is perpendicular to AC. Then measure of angle Y equals 180 minus 90 plus 35. Minus 90 plus 35 equals 55 degrees. And for sure, angle Z has the same measure as angle Y, so it's also 55 degrees. In example number 2, the question says, in the opposite figure, XA and XB are two tangents to the circle at points A and B, where the measure of angle AXB is given by 70 degrees, where the measure of angle DCB is equal to 125 degrees. The question is asking for two things. The first thing, how to prove that AB bisects angle DAX. And the second one is asking you to prove that AD is parallel to XB. Let's see how can we solve this question. Since, as you can see that ABCD is a cyclic quadrilateral, A, B, C, D is a cyclic quadrilateral, therefore the measure of angle DAB is equal to 180 minus 125, which is equal to 55 degrees. Since XA is equal to XB, as two tangents meeting outside the circle at point X, then the measure of angle XBA is equal to the measure of angle XAB, which is equal to what? Yes, as you guys said, excellent. 180 minus 70, and then we divide them by 2. So it's 55 degrees. See, as you can see, both angles are 55 degrees. Then we have now proved that AB bisects angle XAD. And this is the first requirement. To prove the second requirement, since the measure of angle DAB is equal the measure of angle XBA, which is 55 degrees, therefore AD is parallel to XB. And this is the second requirement. The definition says that the inscribed circle of a polygon is the circle which touches all of its sides internally. As you can see here, this polygon ADCB is touching the circle from inside it by all the sides. And here, for this triangle ABC, the circle is touching all of its sides. The center of the inscribed circle for any triangle is the intersection point of the bisectors of its interior angles. Let's go to example 3. In example 3, the question is asking us to find the value of the symbol used in measuring. So, as you can see in number 1, the question wants us to find x and y. Let's start. AC and AB are two tangents meeting outside the circle at point A, so AB is equal to AC. Then x equal 12. MB is perpendicular to AB. As a radius, when it meets with the tangent at point of tangency, they are perpendicular to each other. Then y equals Pythagoras. Yes, good job. Square root of 12 squared minus 5 squared, which is equal to 13 centimeters. So y is equal to 13. As you can see in the second question, in the bigger circle, AB and AC are two tangents meeting outside the circle. So, yes, excellent. They're equal in length. So, 2x minus 3 is equal to 15. From where did I get this? I got this that AC is equal to AB. So, how can we find the value of x? So, 2x equals 18. So, x equals 9. In the smaller circle, as you can see, the two tangents AC and AD are meeting outside the circle, so they're equal in length. We just said that AC equals AB, which is 15. So AD, that is equal to AC, then y minus 2 is also equal 15. So y equals 17. Let's see the coming questions. The number of common tangents of two distant circles. How many tangents can we have in common if you have two circles apart from each other? Let's draw and check. Here we can have one tangent that is common between the two circles. We can have another one. We can have another one. We can have another one. So, in your opinion, can we have any more? Excellent. We can have only four tangents can be drawn in common if the two circles are apart from each other. Okay, how many tangents can we get? How many common tangents can we get if the two circles are touching externally? Yes, we can draw this tangent, we can draw this tangent, and for sure we can draw this tangent. So how many tangents are there? Excellent. There are only 3 common tangents can be drawn if the two circles are touching externally. What if the two circles are intersecting together? How many common tangents can we draw? Here's one common tangent. Here's another common tangent. Is there any more? Good job. There isn't any more. There are only 2 common tangents can be drawn if the two circles are intersecting together. What if the two circles are touching internally? Yes, excellent. As you guys said, that there's only 1 common tangent can be drawn between the two circles. Let's move to example number 4. In the opposite figure, AB and AC are 2 tangent segments to the circle M, where the measure of angle BAM is given by 25 degrees and E belongs to BC, which is the major arc. E belongs to the major arc BC. How can we find the measure of angle ACB? As you can see here, AM bisect angle CAB, and also it bisects angle CMB. So AM bisects 2 angles. Therefore, the measure of angle CAB equals 2 times 25, which is 50 degrees. As you can see also that AC is equal to AB, as they are 2 tangents meeting outside the circle. Therefore, angle ABC is equal to angle ACB, which is the required angle, which is equal to 180 minus 50, and then we divide by 2, which is 65 degrees. This is the first part the question is asking us to find. How about the second part the question is asking us to find? In the second part, as you can see that the measure of angle BEC is equal to the measure of angle ACB. Angle BEC is the inscribed angle, and angle ACB is the angle of tangency. Therefore, the measure of angle BEC is also 65 degrees. By finishing example 4, we came to the end of our session. Thank you very much.